Get Certified Together program is created by Technocofe, your free online knowledge sharing website, based out in London.
We have to make sure that our hypervisor is patched. It should be secure, otherwise someone can hack into our guest operating system and have access to all the virtual machines. These all kind of things we have covered a lot of times. In this particular topic or in this particular domain, we are not really covering that technical bit, how it can happen or what kind of ways someone can come into it and what kind of security strategies you'll be putting there. We'll be more covering towards kind of like management perspective.
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.
Hey everyone, welcome to another episode of Get Certified Together series. This is episode number 35 I am recording today. And like I told you last time that maybe I will not be able to record any news episodes in July and week. That's what happened because I was busy in shifting the home and taking up everything, packing and packing. Good part is most of those things are done and I am ready again to record some stuff which I did to tell you guys about what I did during that whole period, what new things I learned. Remember I told you in episode 34 that I have to give one Kubernetes and Cloud Native Associate examination. Well, I did it last week and I passed it. I will not say it's an easy exam. There are a lot of topics, so it's kind of like it's covering a lot of things, but because it was covering a lot of things and it was an associate level exam, so you can fairly understand that it was easier, but because it have vast number of things to cover, then you of course need to spend some time in reading all of those stuff. For example, covered things related to Kubernetes, some of the basic command lines related to Kubernetes. It did cover something related to containers as well, how you can make sure that your application which is running on pods is highly available, some things related to observability of your containerized system, what are different kind of tools, Grafana, Prometheus, and of course how you can use Git, GitOps to kind of like improve your deployment process, CI/CD pipelines. So there are a lot of things. Good part about this certification is if you study for it, then you will kind of get a good idea about how Cloud Native is developing and what's Kubernetes role in that. So it can give you a kind of good introduction to that field, and if you really like those things and if you really understand them, you find them interesting, then of course you can continue that journey towards learning, doing more advanced certification or learning more towards Kubernetes and other bits related to Cloud Native. But anyhow, it was a good experience. It was online proctored, so I have to set up my laptop on one of the makeshift dining table which I bought last week. And if you have given kind of like this online proctor exam where you have online invigilator who is looking into from your laptop screen, looking into your face and checking your ID and everything, he of course was, I'm not sure whether it's a he or she, but whoever it was, they were asking me again and again about to go through the whole room and see whether everything is secure, everything is clean, because if you have not given that before, then one of the prerequisite is your desk where you are putting your laptop, where you are giving your exam from, should be neat and clean. And because I have shifted recently, my whole house was a mess, but after like around 15 or 20 minutes of check, they finally approved the way I am sitting and the way I am giving the exam. They finally approved it and I just went through it. So it all happened quite well, and I really don't want to cover KCNA as part of next series in this gets certified together once we are done with CCSP, because KCNA is quite basic, and of course you can find a lot of content online related to that. But if you want, I can really cover something related to that. My plan was from CCSP we move to CISSP, which is next level of cyber or info security. But of course, if you want me to cover KCNA, just let me know. I can cover KCNA as well. It's not that big a thing, and I can really do it in maybe 5 or 6 episodes. It's not that big. Anyhow, that's what happened with KCNA. I am planning to wrap domain 3 today, although when I was going through the topics, domain 3 have one big topic related to business continuity and disaster recovery. I thought I can cover it in one episode itself, but seems like there are a lot of things related to that. Let's see if we are able to wrap up everything from domain 3 today itself. Otherwise, by next week, the next episode number 36, we will be finishing domain 3, and I think we will be 50% off from our actual syllabus then. So that's it, and let's quickly move on to our today's topic and today's episode. Before we move into that, let's take a quick short break. Alright, first thing first, the way we always do in our episode, that we cover what I've done till now. So till now in domain 3 itself, we have covered everything related to cloud infra security. We have discussed about various risks associated and various strategies to mitigate those risks. Now we have covered layer by layer. If you remember, we started with bottommost layer, which is a hardware or physical infrastructure. On top of that, there is an operating system, there is an hypervisor which is doing virtualization, and on top of that virtualization we actually put our virtual machines or containers which are then running our application. So there are a lot of layers. If you are using a private cloud, then you have to deal with everything end to end. The whole stack will be coming under your ownership. If you are running public cloud, then it's slightly upward. You don't need to deal with those physical infrastructure part, but you still have to deal with virtual machines and all those identity and access management things, everything related to port security, network security. So you will have kind of like an shared ownership between your cloud service provider and you yourself as an end user. So we have covered bits and pieces related to that cloud infra security in this domain 3. Moving on in today's topic, we will be starting off with virtualization system control. Now, I know virtualization we have covered a lot of time. By now you will be kind of like bored with the repetition of same thing. Yeah, we have to make sure that our hypervisor is patched. It should be secure, otherwise someone can hack into our guest operating system and have access to all the virtual machines. These all kind of things we have covered a lot of times. In this particular topic or in this particular domain, we are not really covering that technical bit, how it can happen or what kind of ways someone can come into it and what kind of security strategies you'll be putting there. We'll be more covering towards kind of like management perspective of that whole virtualization system security. Now when I say management, it's not really about your management, the people. It's about the management plane, the control plane, which is being used to access your virtual machines. Because there will be some end users, there will be some administrators, some sysadmins, some database administrator who will be accessing your machines. So they will use a control plane, they will use a management plane. Now that management plane can be a simple SSH access to your VMs, can be something related from the API, so they can send requests from port 443 and send HTTP API requests to your end system. They can even do RDP session. If you are using a Windows machine, you will be using RDP sessions in that case. So all these different ways of accessing that end system and machines comes under the part of control plane, comes under the part of management plane, because someone is using that management plane to manage your infrastructure, manage your applications. And of course, we have to make sure that it's not open. No one can have like simple SSH access to everything. Only those who are authorized to do it can really do it. No one else can come in and SSH in or can create an RDP session or can send even a simple API request as well. So those API requests also need to be authenticated via some kind of tokens, some kind of authentication mechanisms. Everything can be authorized to the relevant people using role-based access control. We have discussed it multiple times before as well. There must be a role-based access control somewhere. Only people who are authorized to perform some activities, they are associated with a particular role. They can be sysadmin, they can be read-only user. Associate those roles to those set of user, and they will be then allowed to work on your virtual machines or on your virtual infrastructure which is running on top of the cloud. Another thing which is important is isolation. Now isolation can be in the two ways. If you think in terms of like a broader perspective, there are two ways of isolating system. One is network isolation, where you create different VLANs or create different private networks. Each private network is not routable to another private network. They are completely two different interfaces. That's quite good way, right? And of course, that's the recommended way as well. You have to have a network level isolation. So we can have, like I mentioned, using VLANs, using different private networks, tagging your network with different ASNs if you are using a BGP session. So there are a lot of ways in which you can isolate on network level. Beside network level isolation, you do need is multi-tenancy, which is kind of like application level isolation. So for example, you can have inside your organization, you have kind of like multiple teams who are having their own workloads deployed on top of the cloud. So they are kind of like different tenants to your cloud system, and they must be having access to their own project wherever they are hosting or they're loading their workloads. They cannot have access to someone else or some other teams, some other department's workload, some other department's infrastructure. That's multi-tenancy. In terms of public cloud, this multi-tenancy can range from department level, and of course it go all the way from different customer itself. So like I am a customer of AWS, I have deployed my workloads on the same physical infrastructure. Some other customer will be deploying their infrastructure as well. And it's AWS ownership to make sure that those different tenants are always isolated. So this is kind of like application level or infrastructure level isolation, which we simply call as multi-tenancy. You can correlate it with the different tenants living in the same building, and they are living in the same building in different rooms, and they are having their own private isolation. No one is having access to someone else's room, and that's how something is happening in the cloud as well. A lot of customer, a lot of tenants are there, and ideally in the real world, the recommended secure world, those all customer, those all tenants must be isolated. And last but not least, again and again we repeat this thing, everything need to be monitored, everything need to be logged. So who is coming in and out, what kind of activities are happening onto your system as well as inside the system. Now this is something which happened recently as well in one of the project which I was looking apart from my day job. So that customer was actually having cloud event logs onto the AWS, and they thought that that's the only level of logging it should be enough, but it's not, because virtual machines are deployed on AWS as well. What is happening inside those virtual machines also need to be logged in. Every machine generates their own system log, syslogs. Those syslogs also need to be captured and stored somewhere. And that's the whole foolproof strategy. What is happening on your cloud system? What is happening inside the application or inside the machines which are deployed on top of your cloud. Everything, if you then correlate in case there is an incident happening in your system, you need logs from everywhere. And these all logs from different layers, different systems can help you correlate what really happened during that outage or during that incident. Logs should be recorded from everywhere and they should be stored into a third location. That's kind of like a prerequisite again. So if you try to understand from virtualization system security perspective, of course, those strategies like patching or that you are using up-to-date software, that's one of the things. Beside that, there are a lot of other things as well which comes into picture when we discuss about virtualization system security. Now we discuss about role-based access control during this virtualization system security discussion. Let's dive deep into that. What is role-based access control? And let's go one layer up. How you are implementing that system, who is responsible for that, or what kind of defense solution are there in the market. Now role-based access control itself is part of, if you remember, AAA, authorization, authentication, and accounting. Now, role-based access control is part of authorization, but let's start with authentication. Authentication is when you prove yourself who you are using some kind of identity. We discussed about multi-factor authentication in the CompTI as well. So multi-factor authentication is when you have another set of credential or you use another set of like OTP or some kind of biometric mechanism to prove one more advanced level of information related to you, which really prove that you are the real identified user who should be coming in, who should be allowed in. Now, if you are allowed into the system, doesn't mean that you are authorized to do anything inside that system. That authorization comes as part of role-based access control based on your role, what kind of role you have, can be based on your attributes, whether you are a manager or whether you are just an engineer, you are a new joinee. All those attributes can also impact what kind of authority you have once you are inside the system, once you are authenticated. After authorization, what things you are doing comes under the part of accounting, where all kind of activities you did as user, logged in into the system, you ran some commands, or you went from system A to system B, whatever things you did while your whole session was running must be accounted and must be kept as it is, so that if something goes wrong, we know that during that window of time, who are the users who logged into that system. So accounting is quite important as well. Now we have a lot of solution in the market which provide this whole system capabilities. Simple, in AWS by default, they have their own IAM, where IAM is identity and access management. Using that, you can create user, you can define permission, what that user can or cannot do inside that AWS account. Something similar is in Azure side as well. You have a different kind of subscriptions, and inside that subscription, you can then create roles and users. Of course, you have Microsoft Active Directory, which is kind of something which was there on-prem as well, and now in the cloud they created Azure Active Directory, so you can do something similar from that. But what you really want in ideal world is a single sign-on kind of thing, where you have a single credential, and those single credential should be able to authenticate in different number of devices. Now there must be a question in your mind: if we are using same credential to access different solution, doesn't it make it more riskier, because you are kind of having, if your one credential are breached, someone have access to everything? In a way, yes, but it's easier to control as well. If your one set of credential is breached and security identifies that these credentials are hacked or they are not in the safe hands now, they can block it from that single source and all the access will be blocked right away. That's one of the way of thinking as well. You have a single source of truth. Using that, you can access everything. But if something goes wrong, you can block from that source of truth itself, and everything will be blocked from access. Now, single sign-on, of course, Microsoft Active Directory, I'll mention again. That's one of the biggest or most used application for single sign-on. Single sign-on works in kind of like an identity provider and system model. So identity provider is, of course, like for example Active Directory, where you are creating all the credentials, all the users and their password, all the details related to their department. Now remember, this identity provider is only used for authentication. You may or may not have authorization in that solution itself as well. So in case of AWS, for example, if you are integrating AWS with Azure or with Microsoft Active Directory, you are only using single sign-on to authenticate. Authorization can still be controlled by AWS. AWS can still create their own policy to block or unblock certain level of access for that user. So it's kind of like complicated if you really think over, but this whole complex nature actually make it easier for security people to control the access, to control who can go in and out, because they have single source of truth. And that single source of truth can be achieved by single sign-on, and that single source of truth help in controlling or help in avoiding any major damage if there is really some kind of like access breach. Now, while we are discussing about this authentication and authorization, it's a good segue into our next topic, which is auditing. Auditing, just from simple word itself, you can understand that you are checking something. Someone is coming in and checking what you guys are doing, how your organization is looking like. Are you following all the compliance? Are you following all the strategies which should be in place? If you are having some kind of like PCI DSS or some kind of HIPAA related data, are you following those standards? Auditing in cloud is complicated because we have shared model, right? So maybe some recommendations which are there related to your physical infrastructure, you can't really control if you are using public cloud, because in case of public cloud, physical infra is not in your hand. It's with AWS or Azure. They won't let you in and go to their data center because your auditor wants to audit something, right? They won't give that permission. That actually complicates things a bit in case of public cloud specifically. In case of private cloud, of course, you own everything. You can showcase to your auditors everything. You can show that these kind of strategies are in place for physical infrastructure. These kind of strategies are in place for virtualization layer. You can go through whole stack and showcase everything to them. But in case of public or hybrid, you're not owning everything. So you have to rely on AWS or Azure or Google Cloud for doing their bit, for complying with certain standards. Only then you can actually, of course, rely on them, and you can have kind of like this blind trust on them that they are doing their part while you are doing your part. Now, this complication is not only related to physical infrastructure, it's also related to other things as well, like logging, like packet tracing, because all these cloud service provider, they won't give you access to their data center. It doesn't simply means they are not giving access to physical disks or physical servers. They are also not giving access to their networking equipments. They are not giving access to their loggings, what kind of logs are created in those systems. They are not giving access to what traffic is going in and out, what are different hops, different endpoints. You are completely blind in that case. And that's why it's getting complicated and complicated. But there is a plus point as well. See, all these businesses, AWS, GCP or Azure, they are big companies, they are big organization, and their revenue, their business from you or end user is dependent on providing a secure environment. Instead of you getting worried what is happening in their data center, they are more worried than you. They are more worried that everything is secure. They are making sure all the strategies in place. For example, if you go to AWS Marketplace, you will find a lot of images there, a lot of operating system which you can use to deploy a machine. But onto that marketplace itself, you will find specific standard images as well, which are compliant, for example, with CIS benchmark, which are compliant with by default for PCI DSS data, which are even provided by official authorized vendors. For example, Canonical provides an official Ubuntu image, so don't use any open source or any Ubuntu image you found on marketplace. Use the canonical one. If you rely on AWS or if you rely on Azure for all these nitty-gritties, you are kind of saving yourself from the headache, because they are doing their bit and they are, trust me, more serious than you to make sure everything is secure. Because if something goes wrong, someone hacks your data from AWS data center, it's more reputation loss for them instead of you. So they are doing their bit a lot more seriously than end users, and ownership on end users to make sure they are doing their bit as well. Otherwise, if something goes on your virtual machine, AWS won't be responsible for that if you are not doing your part. And that's the thing, if you are discussing about auditing, there is always a risk associated if you are having a deployment on public and or hybrid cloud system, but there is a plus point as well. Alright, let's make this episode a bit longer because I really want to finish domain 3 today. Let's discuss about business continuity as well. Now, business continuity and disaster recovery, both are the things we have discussed again. I think this statement is quite repetitive now. Most of the things which we are discussing in every episode are kind of repetitive. But that's the good point, right? You will get to revise everything and you know that whatever you read or learned before is used again and again and is always relevant. So for business continuity, if you remember, business continuity is strategy to make sure your business is always up and running even when there is a disaster. So business continuity simply means your business should be always up and running. Disaster recovery is after there is a disaster, your business is still continuing, but during that disaster, you must have lost something. Maybe your standby site, maybe your active application, maybe your some kind of like data which has been lost due to that disaster. Disaster recovery deals with recovering that data, or recovering that application, recovering that site. Your business is still continuing, which is part of business continuity. But disaster recovery deals with recovering what you lost. And that's kind of like a correlation between these two. So you cannot say these two are completely different things. Also, you cannot say these two are same things. So kind of related. One thing is triggered. Business continuity deal with continuing the business. Disaster recovery deals with recovering that disaster. That's the only difference between two. Now, in terms of cloud, what kind of things you think are creating risks which ultimately lead to disaster or which make you think over business continuity? Now, in terms of cloud, what do you think will be the risk related? Well, one of the risks is because you are creating your own application, your own virtual machine. Are you creating a standby virtual machine as well? If you are creating standby virtual machine, are you making sure that those two are able to talk to each other? How you created them? Did you created them into the same availability zone? Did you created a geo-redundant virtual machine? If you are creating a kind of like container system, what kind of AKS or EKS Kubernetes cluster you are using? And beside this, of course, how your networking is looking like. Whether the standby site which you are creating is onto the cloud. Maybe you can think, if I'm using a hybrid cloud, I'll create a standby site onto my private infrastructure. Or other way, if your active site or active application is running on private, maybe you think that I can create standby on the cloud side. But who is actually owning that networking? Who is making sure that those two sites are reachable? All these risks are associated with business continuity. And of course, there is a big adverse scenario if whole Azure data center or whole AWS data center goes down. Have you taken in consideration that disaster as well. If you're putting something onto the cloud, who is owning the backups? Who is taking the backups associated with that application or with that virtual machine onto the cloud? All these are risks which are related to business continuity and which make you think over how we can deal with this kind of scenario if we are having some application onto the cloud. Now, for business continuity itself, we have to understand about three different terms: RTO, RPO, and RSL. Now, RTO is recovery time objective and RPO is recovery point of objective. And let me define all these three from the example itself. For example, today on Wednesday, you have taken one backup. Something happened to your application on Sunday. So your last backup is what? The one taken on Wednesday. Something happened on Sunday, you are able to recover your application by next Wednesday. So your recovery point of objective is last backed up data, because application which you restored on next Wednesday will have the data which is last backed up on today, which is Wednesday. So you will have from one Wednesday to another Wednesday, you have the first Wednesday as recovery point objective, the point from where you were able to restore everything. So everything before today will be there in the application. Everything after today will be lost. Your recovery point of objective is the point up to which you were able to restore your application, restore your data. Recovery time objective is the time which was lost in recovering that application. So remember, something happened on Sunday and you were able to resolve that issue and restore your application on next Wednesday. So the time between Sunday to Wednesday is your recovery time objective, which is your RTO, which is the time when you were able to restore your application. So when we talk about business continuity or when we talk about disaster recovery, we have to take in consideration these two aspects. If we have a longer RPO, then it's kind of like defies the purpose, right? Because if my application is backed up 1 month back and I lost my application after 1 month, that whole 1 month data is gone. So my RPO should be as closer to my disaster. Only then I will have kind of like more up-to-date information. And that's why the business critical application should have to be backed up maybe every day or every day 2 times. So anything happen, you have a short up time period of recovery point. Same goes for RTO as well, that RTO should be less and less. So if something goes wrong, you should be able to recover the application in maybe half a day or 1 day. So you can have recovery time of maybe 1 or 2 days at max if you are having a business critical application. And that's the key business requirement. These RTO and RPO values always decide whether our disaster recovery plan is foolproof, whether we have put in all the strategies to make sure that our RTO and RPO are less and less. Now, RSL is slightly different than these two. While RTO and RPO talks more in terms of time period, RSL talks in terms of resources which are required for your application to come up. So for example, your normal CPU utilization is 20 or 30% in your normal working environment when everything is normal, there is no major outage or anything. Something goes wrong, of course you have to deploy more resources to bring that service back. These resources can be in terms of like physical infrastructure resources can be in terms of actual engineers who are working day in and day out to recover that application. You are increasing the utilization, and that utilization is calculated using RSL. So RSL is also important because it actually defines that how much resources will be required if something goes wrong to recover your application. So again, I repeat, RTO deals with the point when you recover your application. RPO is the point from where your last application is backed up. So the point from where onwards you lost everything. But before that, you are having everything and you have recovered everything. And RSL deals with how much resources you put in to bring that application up when there is a disaster. Now let's collect all the thoughts and discuss about the plan or strategies for BCDR. So your BCDR strategy should cover a shorter duration of RTO, RPO and RSL. So you have less and less utilization. You should be having less and less loss of data. You should be able to recover everything faster. You have to decide whether you want to put your standby site onto the cloud or onto the on-prem. So you have to decide on location as well, which really determines how serious you are in terms of making sure your business is always continued or there is a proper disaster recovery solution in place. A regular backup solution, a proper mechanism, maybe some kind of like extra licenses as well. If something goes wrong with your one of the application, you should have some kind of spare license to bring up a standby site. So you have to make sure your licenses are also there. You have ample number of extra resources to bring that site up. Of course, decide on whether you want to put your standby site on cloud or onto the on-prem. Your network connectivity should be also there. Maybe you even decide to divide your application as well. So maybe your front end is running onto the cloud while your backend database is running onto the on-prem. There must be having some kind of cross connect as well. So if you have one full stack of front end backend onto the cloud, one full stack of front end backend onto the on-prem, they must be cross connected. So your front end onto the cloud should be able to talk to back end onto the on-prem and other way as well. So front end on-prem should be able to talk to the back end onto the cloud. All these cross connect will make sure your application is always up and running, your business is always continued. And in case something goes wrong, it's easier to restore the application or it's easier to restore the data if you have kind of like a time space. If you have everything up and running in the standby side, then your engineers or your end users will not bother much about the time taken for RTO. But if you are losing a business critical application which should be up within 1 or 2 days, your engineers, your sysadmins have to work day in and day out to bring that application up. And all this time and effort you can really save if you have like a proper business continuity and disaster recovery strategy upfront in place. Of course, it will cost you more. So maybe in initial days, management will give kind of bit nagging that why we want to spend resources right away, why you want to buy more and more resources when you have already one.
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.
One stack or one set of application up and running. Always make them understand that we need a standby site if something goes wrong, otherwise they will be breathing on your neck. Alright, finally with this we finish domain 3. We will be covering domain 4 in the next week episode, and domain 4 actually deals with cloud application security. Now me myself is an infra guy, so this domain 3 was a cakewalk for me. Application security will be a bit trickier for me as well, so I have to invest my time. Please make sure that you also invest your time. One more thing, I'm sure you all made ISC Square account and you are somehow connected to your local chapter, but if you still haven't, then contact with me. I will help you guys there. And last bit of announcement, ISC Square provides one certification free if you create their account, so you can have CCSP free of cost, the registration for that certification. And that's a big news for us because otherwise this certification costs around $500. So make sure you create your account and get that free coupon code so you can get a free CCSP certification chance. Alright, that's it for me for this week's episode. Tune into next episode when we will start with domain 4. Goodbye and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.